Hello GATE aspirants, welcome to part 8 of GATE solid state physics series. Question number 7. The atomic mass and mass density of sodium are 23 and 0.968 gram per centimeter cube respectively. The number density of valence electron is up to 2 decimal places. Now we know density is equal to mass upon volume, and that will be N effective into mass upon Na into A cube, that will be volume of that unit cell, where N is N effective upon A cube. So this will be the number density. So from here, N effective upon A cube, that will be rho into Na, density into Avogadro's number upon mass. So N is equal to, density is given 0.968 gram per centimeter cube into Avogadro's number is 6.022 into 10 raised to 23 upon mass is, it is in gram, so this will be 23 gram mole. So this will be per mole. So everything will cancel out and then answer will be in centimeter cube. So this N comes out to be 2.534 into 10 to the power 22 centimeter cube. So rounding off to 2 decimal places, it will be 2.53. And the answer range for this question was 2.50 to 2.55. So answer is 2.53. Next question. Consider a one-dimensional lattice with a weak periodic potential U of x is equal to U naught cos 2 pi x by a. The gap at the edge of Brillouin zone k is equal to pi by a is. Now here it is given U of x is this. So I can write U of x plus a, where a is periodicity of that function. That will be U of x, it will be same. Now U of x is equal to what? It is U naught cos 2 pi x by a. Now I can separate this. So this will be U naught by 2. In bracket it will be e raised to I 2 pi x by a plus e raised to minus I 2 pi x by a. Now this part is standing wave. So this is a standing wave, because it is e raised to ikx form. So this is a standing wave. And then we have to find out gap at the edge of Brillouin zone. So that will be delta U will be, it will be U naught by 2. This is the amplitude. And since we want the entire gap, so we have to multiply by 2. So this will be U naught. So here option A is correct. Next question. Consider a two-dimensional electron gas with a density of 10 raised to 19 per meter square. The Fermi energy of the system is dash. Now in 2 dimension, EF is equal to, EF is Fermi energy, is equal to h square by h cut square by twice m into 2 pi n. So this can be written as EF is equal to h cut is h by 2 pi. So after substituting it, we will get h square. This 2 pi will cancel out, and 2 pi into 2 is 4 pi m. That will be EF. So h is 6.63 into 10 to the power minus 34 the whole square into n is 10 raised to 19 upon 4 into 3.142 into m. That will be mass of electron. So that will be 9.1 into 10 to the power minus 31. And this we want in electron volt. So we have to divide by 1.6 into 10 raised to minus 19 as well. So the answer will be in electron volt. And this comes out to be 2.34 electron volt. And the answer range for this question was 2.32 2.40. Next question. The total energy of an inert gas crystal is given by E of R is 0.5 upon R raised to 15 minus R1 upon R raised to 6, where R is the interatomic spacing in angstrom. The equilibrium separation between the atoms is. So for equilibrium separation, we just have to take derivative of E with respect to R, and it has to be equal to 0. So this derivative will be 0.5 into I raised to minus 12, so that will be minus 12 into 1 upon R raised to 13, then minus 1 into minus of 6 into 1 upon R raised to 7, that will be equal to 0. So 12 into 5 is 6, so this will be minus 6 upon R raised to 13, and this will be plus 6 upon R raised to 7, that is equal to 0. So from here we will get R raised to 13 is equal to R raised to 7, that means R raised to 6 is equal to 1, that gives you R is equal to 1. So this is in angstrom, so this will be 1 angstrom. And the answer range for this question was 0.90 to 1.10. Answer is 1. Next question. The real space primitive lattice vectors are A1 is equal to Ax cap, A2 bar is equal to A by 2 x cap plus root 3 y cap. The reciprocal space unit vectors B1, B2 for this lattice are. Now we will consider third vector as well, A3, and that will be k cap. For calculation purpose we require it. So let me write z cap here. Now first of all let us calculate the volume of this primitive lattice basis. So that will be A1 bar dot A2 bar cross A3 bar, and that will be Ax cap, and in bracket we have A by 2 x cap plus root 3 y cap cross z cap. So this will be Ax cap, and then we have A by 2 x cap cross y cap, that will be minus of y cap plus root 3 A by 2, and y cap cross z cap is x cap, and then this will be x cap dot s cap, that will be root 3 A square by 2. So that is the volume. And for reciprocal lattice vectors, A1 star is equal to 2 pi. If you are calculating 1, then here it will be A2 bar cross A3 bar upon this volume thing. So this is volume, so upon volume, that will be 2 pi upon root 3 A square by 2, and this will be cross product of A2 and A3, but we have just calculated this, na? So let us use that. So this will be minus A by 2 y cap plus root 3 A by 2 x cap. So this will be, if I keep 2 pi by A here, then this will be 2 pi by A, and in bracket we will have x cap, because this root 3 and root 3 will cancel out, minus this will be 1 by root 3 into y cap. So that will be value of A1 star. So that is one thing. Then let us calculate second part as well. So that will be A2 star, and that is equal to 2 pi into, if you are calculating A2, then here we will have A3 bar into A1 bar cross A1 bar upon the volume thing. So this will be 2 pi upon root 3 A square by 2. Now take cross product of z cap with Ax cap. So z cap cross Ax cap. So this will be A and A will cancel out. So this will be 4 pi upon root 3A into y cap. So option A is correct. So these were all the questions from GATE 2017 paper. from solid state physics part. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.